Okay, hello again. So let's look at analytical techniques. Now for the AS course, this is only about infrared spectrophotometry. So where light source being shone onto an sample of an organic compound. Now the interesting bonds within a molecule absorb energy at different frequencies, and different bonds absorb differently, and they do all kinds of stretching, or whether it is wagging or twisting and rocking. Luckily, we do not need to know the ins and outs of that. The detail of that is not required. All that we need to know is that we can use infrared spectroscopy to identify certain bonds in a molecule. So let's just quickly look at the profile that we will get. Profile would be, or would have, a wave number at the bottom at the x-axis and transmittance at the y-axis. Now, what does the wave number refer to? Well, the wave number is the number of waves in 1 centimeter, and it has the unit of centimeters -1. So, and wave number is inversely proportional to wave length, which is then directly proportional to the frequency, and frequency is directly proportional to energy. So the wave number actually is very conveniently to show us the energy, or in which range the energy is absorbed, and that gives us the indication of where the bonds lie. Now, on the y-axis is transmittance and absorbance, and these are terms that you might already know since primary school. What does transmittance mean? Transmittance means if I shine a light on a glass of water, some of the light penetrates and is seen on the other side, so it's transmitted through the glass of water. So that's what we pick up. Absorbance, well, that's the other part of it, the amount that is absorbed by the substance. So if we have a transmittance of 0.2, it means 0.8 of that particular wavelength or frequency has been absorbed. Okay, so, and this is basically what we said in here. If we look at this example that we have, is propan 1-ol. So propan 1-ol, there's a hydroxide group, and there are lots of carbon-hydrogen bonds in there. This is a profile that shows the different regions in my profile. So in the next slide, we'll look at this region below 1500 is known as my fingerprint region, and above 1500 is known as my functional group area. Okay, so we are only interested in the region of 1500 and up. This tells us that there are two peaks in there. Now this peak just below 3000, about 2900, is my carbon-hydrogen bond. It doesn't tell us something significant because all hydrocarbons contain that. But this part of the 3300, that strong peak, I know it's known, if we do wave patterns, it's a trough, but we refer to it as peaks in these profiles. And this is indicative of the hydroxyl group. Okay, so just what we said, fingerprint region doesn't tell us really much. It gives us more detail of the length and how the interactions are within a chain. But above 1500 gives us the information we require of specific functional groups. Take note, I know this is not what is supposed to be on this slide, the information, but around here, 1700, if there's a strong, sharp peak over there, it's usually my carbon R group, my carbon double bond oxygen. Okay, so just to show and reiterate our fingerprint region, here we have two alcohols, a propan 1-ol and a propan 2-ol. Again, what is the same? Look at this. There is my alcohol group, there's my alcohol group, there's my carbon hydrogen, there's my carbon hydrogen. So for my functional group area, this side of 1005, it's identical. But my fingerprint region looks dramatically different. And that's because of the difference in interaction is what is happening there, where my alcohol is bonded. This is a primary alcohol, this is a secondary alcohol. Okay? So again, we can't use that data. Therefore, when you go into A levels, we will do something like nuclear resonance and some chromatography and other tests to define or to get to know the molecule better in that sense. So this is likely what you will get in your data booklet. So you don't need to know the specific values. You will get a profile and you'll be able to use the data from this to identify which functional group there is. Look at this. So there's a free alcohol in there. We have a specific value. If we have an alcohol, an OH group, hydroxyl group, that is bonded to a carboxylic acid, it's much lower, but it's much broader. Right, so let's go look at examples. First of all, ethanoic acid, we have got various bonds in there. Carbon R group, carbon oxygen, oxygen, hydrogen, carbon, carbon, carbon. Now, carbon, hydrogen is in any molecule. But my oxygen, hydrogen, and carbon, oxygen, carbon double bond, oxygen is going to give us a better idea of which functional groups we are dealing with. So that's what we're looking for. If we look at our fingerprint region, not much. That could be if we look at our values of carbon, oxygen bond, but question mark, we're not sure. What is definitely sure is around 1700 we have a carbon R group. That's a strong peak. Around 2800 to 3300 we have a very broad, strong peak. That tells me there's an OH bond that is linked to a carboxylic acid. Hence, this is a carboxylic acid functional group. And that's all that we can say. We can't say how long is the chain. We can't say anything else about it. Note that my carbon-hydrogen bond over there has almost been taken up by that very broad peak in there. Okay, so not very noticeable, but it also doesn't tell us much because it's carbon-hydrogen. It should be in there. Right? So this is what we've mentioned now. And remember, the range that we state comes directly from our data booklet. So don't go and try and measure and use the values in your data booklet. What we've talked about in my carboxylic acid is still just everything that I said to you guys now. So if we just look at a normal a normal alcohol, have a look. My peak for my OH group, a free alcohol group, is shifted. It is much higher than when it is connected to a carboxylic acid. Also, this peak at 1700, it should be a strong peak, is not there. So it doesn't contain my carbon R group. And my carbon hydrogen is much more visible. So this is just a normal alcohol. Right? The more you see the profiles, the better you'll get at distinguishing. What about an ester? If we look at an ester, it doesn't contain an alcohol group. There's no OH bond in there. So you see, there's no deep and broad trough over there. What is it? hydrogen bond. That's shown over there. But what there is my carbonyl group, my C double bond O, and around 1700 there is my very strong peak that shows that. So at around 1740, I think, according to this and my data booklet, we should see our carbonyl group. Okay, ketones and aldehydes look very similar, right? They also have only my carbonyl functional group, and depending on the length of the chain, the amount of your carbon-hydrogen bonds, this peak will grow a bit larger, but it's not indicative of anything. So how do we differentiate between an ester, an aldehyde, and a ketone? Well, this will be through reactions that we do. They react differently. So in a question paper, they will give you additional information to the profile to distinguish it. Okay. Hydroxy acid. What's hydroxy acid? Well, hydroxy acid is where we have our carboxylic acid group plus another hydroxide group. What happens? Well, my carbonyl group is there, so we have a very strong peak at 1700 due to my carbon double bond oxygen. But look at this broad peak, and this shows up because of my because of my hydrogen and oxygen bond in there. The amines, just to basically end off, because we can get something about amines. Amines, we have a nitrogen hydrogen bond, and that is a double trough. And I say a double trough in here, where we have our carbon hydrogen and our nitrogen hydrogen bond in there. So you can recognize the profile as well. This isn't as sharper and broader peak as with my hydroxides. It is a bit more shallow, weaker in that sense, and not as broad. So we haven't seen many amines asked, but they can ask amines. Right, so that's in essence what you need to do. We'll work through the worksheet, and then as we move through the other reactions and properties of our functional groups, we'll revisit the profile as it comes up in exam questions. Okay, thank you.